there's not even different bonds. They have all the same bonds. They are stereoisomers, which just means basically in one of them, I think it's a methyl group. No, it's not a methyl group. Anyway, in one of them, a bond is going that way, and in the other one, a bond is going that way. And if you try to take these molecules and superimpose them, impossible. Okay? Good thalidomide, great morning sickness drug, help lots of women and stuff like that. Never approved in this country. Bad thalidomide was caused birth to children to be born without limbs. No arms, no legs, and stuff like that. So, yeah, I mean, it's absolutely critical that you know what the chemical is unambiguously. Yeah. Anyway, that was a random story. It was a very good story about stereochemistry and stuff like that. Okay. So this is 1-methylcyclohexene. Okay. Those are our anticipated product. As you guys know from last week, doing your eugenol and stuff, sometimes, we get streaks on the bottom of our TLC, and who knows what the hell those things are. Okay. Luckily, next week, we're going to use something called gas chromatography to try to identify what, do we see the main expected guys? Okay. And, what's the streak on the bottom? What are the other unexpected compounds? Okay. But these are the expected ones. All right. One last theoretical thing before I just show you your setup and everything. In every alkene in the world, there's 4 positions. Agreed? You get 2 carbons, 4 positions that come off. Okay. So, you know how you've talked about primary, secondary, tertiary, and quaternary carbons? We do a similar type of classification for alkenes, okay, based on those 4 positions. How many of those 4 positions are carbons? Okay? If none of them are carbons, it's called unsubstituted alkene, all right? Otherwise known as ethene. If it has 1 carbon on there and the rest are hydrogens, then it's called monosubstituted. Does that make sense? All right, so nice monosubstituted. Okay, substituted. I want to write it on the wall. Carbon thingy thing, the rest are hydrogens. Ah, come on, Bert. Sorry. Unsubstituted. Mono substituted.
Wait, in the first one there are 2 carbons, but that's still unsubstituted? Or is it?
You don't include the carbons
on the double bond.
Right. We're just talking about the 4 different positions. Okay, so this is di-substituted. Note there's a couple different ways you can create a di-substituted alkene. I could have put the R on both R's on the same carbon and both hydrogens on the other one. Yeah? And both of those would be di-substituted. Okay, that's Trump. Tetra substitute. Okay. As it turns out, the more substituted an alkene is, the more stable it is. All right, for reasons which I will let Dr. Horton go into. Okay, they're a little bit complex, and I don't want to get distracted by that. So, the more substituted, the more stable. We go down, increasing stability. Okay. Frequently, things that are products that are more stable versus a product that's less stable is more likely to get made. That's probably not shocking. It's probably somewhat intuitive. The more stable product, more likely. It doesn't have to be that way, by the way. There's no rule that says that. All has to do with your energy of activation. Is that a term you guys know? You should know it from Devon County, right? You did learn it at Devon Camp that those things evaporate in your brains. So, but there is a correlation where frequently, the more stable something is, the lower the energy of activation, and thus the more likely it is to be made. Okay? Now, why do I bring that up? Because not only are we going to care next week about what are the different products that we have from our reactions, but we also care about what's the ratio, how much of it do we have. All right. Okay. Now that I've taught you substituted, all right. How do I describe this one with this type of classification? How do I describe that guy?
Or di-substituted.
Di-substituted. If you're not sure, a check you could do is always, in your mind's eye or on your paper, draw in the hydrogens, yeah? Okay? You only got 2 hydrogens. The other 2 of the 4 positions are carbons, so it's di-substitute. Di-sub. That guy. Draw in the hydrogens in your mind's eye.
Also.
And then do that. It's also a di-substitute. Very good. That guy? Try. Yeah. So, what that means is, foreshadowing to next week, we would actually anticipate that we get more of that guy than that guy, for just that reason. Okay, I am always, me building the reaction setups here is kind of a new thing this semester. Normally I draw pictures because I am a really good artist. No, I'm going to build it. Okay. Yeah, I do. Over the years, I have a great relationship with the lab thing. And so we get along awesome, but I think I've become a prima donna. I want my own. Okay, princess. Get you your own little drawer. All right. So we were doing the reaction in the 5 ml conical vial, which I don't have. Oh, yeah. Was it your section? We had all those funky ones, and I was like, can I borrow somebody's real quick? The bigger one. Yeah, that's awesome. Okay, so, I'm sure I'm sort of in the view of that thingy. Hi, internet. Okay, so we're going to put in a couple boiling chips, right? These are some cool Teflon boiling chips. and you know, shoot, 3 of them is plenty. Okay, they're going to go in here. I'm going to put this in my beaker, and then I'm going to go get my chemicals. Okay, after I do the dry setup, right? We always do the dry setup first. When I'm going around to get my chemicals and everything, what do I make sure I do?
Keep it in the beaker.
Put it in a beaker. Yeah, exactly. So you are going to put in 1.5 mils of, first of all, you should get an empty weight of this dude. Okay? And then you're going to put in 1.5, 1.5, right?
Yeah.
1.5 mils of whichever alcohol you pick. You need a partner?
I think we're uneven today.
Yeah, we are uneven today.
Keisha's not here.
Keisha. Yeah, okay. So, we'll figure that out. Maybe somebody's willing to just be the lone wolf today? Wait, lone wolf? Okay, I'll let you figure that out. All right. Let's do our dry setup first. What's the critical thing when we make this joint?
There has to be that little
Has to be that little black O-ring. Okay. Okay. That goes in there. All right. This dude here. Okay. Gonna be like, oh no, kidding. No. That will cause you to have to redo the experiment. First, what did I forget, guys?
The Hickman.
The Hickman head. Yeah. Hickman head has the same kind of joint, needs the same kind of setup. Put the balloon nut on there first, and then put it on your O-ring. Okay? We here at HBU have the fancy Hickman head, the side port. We don't have to do any of that bending of the tip of the pipette they talk about in there. Okay, you're all good. You just take off that little nozzle when you need to. Alright, so now he can fit onto the conical vial. Okay. And then the condenser fit on there. Okay. Alright. Fits down nicely in that divot. Okay. And I'll look, I can't remember what, I think he takes a little bit more heat. I gotta look at my notes as soon as you guys get started. I'll let you know long before you need to. But one of them takes, you just gotta turn that dial up just a tiny bit more to get it to go. Okay, and you got your hoses connected, right? You go in the bottom and then the top goes to the drain. And then we need a drying tube, okay? There are some fumes associated with today's lab. Oh, shucks. Spatula. There. Okay. Oh. Okay. All right, so we're going to take this. You want like enough so it goes in there nice and snug, okay? But you don't want to take like this whole cotton ball and stuff that in there like a musket or something, right? Probably a chickpea. This is going to do a bunch of things. Keeps the fumes out of the lab a little bit. Oh, no. No. Maybe a little bit bigger than a chickpea. Marble. Not the big, fat, shooty one with the... Marbles. I'm going to ask your grandpa what I'm talking about. All right, then you're going to fill this with calcium chloride. Okay? Calcium chloride is going to grab some of those fumes before they they come out the top of this guy. It's also going to keep excessive water from going in. Okay. These reactions can actually reverse. Okay. So if you take an alkene and if there's a lot of water around, you can end up protonating that, making the carbon. You can do the reverse reaction. Okay. So this will help keep it dry. So you put in, the calcium hydrides over there. You just want to get in, say, an inch. Okay. And then you cap it with another chickpea.
Chickpea or marble?
Oh yeah, we can switch to marble. Okay, another marble like that. Pretend there's calcium chloride in there. This is another one of these ground glass joints, so we need another nut and O-ring. Nut goes on first, then the O-ring. Do me a favor, and when you're setting it up, imagine this is a little Nerf gun or a little BB gun, and point it away from your neighbors or yourself. Okay? I don't feel like I've seen it in years, but every once in a while, for some reason, the student puts up way too much heat down here, and you build up pressure. And I mean, not like, more like pop, but you don't want it to. And you guys are so distant now that it's not as big of a word, but nonetheless. Okay? No stir bar because we've got those boiling chips in there. Yeah, and that's it. And so you'll see the reaction heating up, and you'll start to see stuff build up in there. Okay? You'll have to do an emptying of it. All right? So your product, which do you think has a lower boiling point? Say, your starting material or your product? Your product does significantly because of lack of hydrogen bonding, right? So you're going to have this at a heat such that it will not evaporate an alcohol, okay? That has a very high boiling point, or a relatively high boiling point to what we're doing. But we'll evaporate the product as it forms. That's part of how you avoid this reversing issue, is that you're going to take it out of there before it has an opportunity to reverse. Okay? So the cyclohexene will float up into the air. It will hit this, okay? But then it comes back down the sides. That's why you have this little well, so that it can't go back down into the conical. Does that make sense? Can you guys all see it good? Okay, cool. So periodically, and I think it's usually like 2-3 times top, probably. But you basically want to do it until you stop seeing stuff collect up here. You're going to stick a pipette down in there. I guess it's, oh, something stuck in mine. Weird. Okay. Yeah, I think you can do it with a short one, but there's one stuck in mine. Short one would be better, I think, because these long ones, they will break very easily. So you stick it down in there, and then you take out your precious product and you put it into your 3 ml conical vial that is sitting in a beaker. Okay? And we'll go to all this trouble and then dump your product all over your countertop. Okay? Sound good?
I need your help. Perfect timing.
Yeah. So sorry. Can you wait 5 minutes, son? You're a good kid. All right. Okay, so that's that.
Question.
Yeah.
When we weigh our 5 ml beaker or vial first, do you want it to weigh it with the chips in it or without the chips?
Doesn't matter as long as you're consistent, right? So I would probably do it without the chips if it were me, but you weigh it, write down that weight, go get your alcohol, whichever one you're using, come back and weigh it again. Okay, good question. All right. Here's my notes. Okay. So it's all jacked up. All right, figure it out later. have your product sitting in your 3 ml conical vial. And so you are out of pigment. Okay. Okay. And then you're going to add, gosh, I would have done that on the quiz today. What's the volume of sodium chloride you use? Anybody remember? Is it 1 ml? Saturated sodium chloride?
0.04.
0.04. No, it can't be that crazy, right?
This is 1 ml of the sodium chloride.
Oh, okay. Yeah, what you're gonna do is so I've transferred as much stuff as I can. Now, the water is gonna help get rid of some of the acid, but we can also use it because you'll have some product that's stuck on the walls here. You'll go in there and you'll actually sort of collect it with that sodium chloride. Okay? So, I can't remember how they say it. I think what they want you to do is like this. Put your sodium chloride down the walls like that, and then you can suck it out through the side. Okay? So, let's call this wash. Add with sodium chloride, saturated sodium chloride, which is right there. Okay. Okay. Yeah. One thing that we do different is we don't put it in a test tube at the end. Okay. The more glassware you introduce, the more places there are for mechanical loss. The more places you can have the product sit on, get stuck to glass, and you lose yield. Well, now I've got 2 layers, right? Okay. I actually put my arrow someplace else. We don't need it anymore. I still, I don't like to throw away things until I know I took out the right layer and stuff. So I would probably take that bottom layer. Like that bottom layer, which is your aqueous sodium chloride layer, into TT, test tube. Okay. That will leave you with just 1 layer. Now, what you're going to do is you're going to add, rather than sodium sulfate, which is what they describe, you're going to use magnesium sulfate. Add around 1/3 volume of magnesium sulfate. Okay? So, if my little blue line here is how much product you got visually, and this isn't, you're not looking at tons of product, so don't worry too much, okay? If that's your product there, then I'm adding magnesium sulfate. This could be 1/3 or even 1/4 magnesium sulfate, so you just need to judge that. Does that make sense? That's a drying reagent that will get out any residual water that we didn't get out earlier. I would say when you're doing this pipetting layer, try to make sure you don't suck up some product. If you had to leave just the tiniest bit of water behind, that's better than sucking up some product, because the mag sulfate will get that tiny bit of water. All right. But then we've got the magnesium sulfate mixed up with our product, so we need to deal with that somehow. This is how we're going to do it. We're going to create a pipette filter. Now I will show you how to do one here in just a second. A pipette filter is simply one of these glass disposable pipettes with a tiny bit of cotton in it. Okay? And I usually break off this guy. Okay? And then that's a shell vial. Pre-weighed, that's important. With cap. Okay. These products are somewhat volatile. I mean, if you made your cyclohexene product and then you left it out on the countertop for a couple hours, you would have no product. It'd be all gone. So these are shell vials. Okay? All right? And so now what I can do is I can take another pipette and pipette that stuff out, run it through this pipette, which is clamped, and I'm going to build one here for you in just a second. Okay. Drop. Grabbing that stuff, putting it through my pipette filter, down into that dude. Once I've done all of it, okay, I'll put the cap back on, go weigh it, and go count flies. Does that make sense? All right, let's show you how to build the pipette filter real quick. So, I think actually maybe the only reason we have the long pipettes out today is for, is that what I want to do? Yeah, I'll take one of these long bags. And it does not need to be much cotton. You use too much cotton, that's going to suck up some of your product, lower yield. Like that. I've got this guy in a beaker, obviously, so that it doesn't affect that. Does that make sense, guys? Got all that? Okay, awesome, awesome, awesome. The other activity you have to do today is to count your flies, okay, with your partner. All right, and then it's very important that you come in and you tell me what dose you did and what you got in each trap. Okay?
Where are they?
I'll get to that in just a second. So, what you need is I think 2 paper towels. Okay. You need your spatula. All right. And you're going to go out there. I'm going to lower the lines, do kind of high, catch flies and stuff. Don't be sad if you have some zeros, okay? Especially lower doses people. Okay, that's fine. I'm sure somebody that put in 50 milligrams and has the thing filled up with fly carcasses would be happy to have you help them. So you take the thing off, okay? You dump it onto your paper towel. You can use your spatula and then you just count the flies, okay? And you do this outside. Don't bring that mess in here. All right. All right. And then I'm going to put a trash can out there. You just throw everything away. And then I've got all the strings that are holding your traps are being held on by these dudes. I need these dudes back, okay, so we can use them again. And then come in here and clean out your vials really carefully with soap and water. Make sense? Questions?
Disposal stuff.